Welcome back to the basic HAL tutorials for Linux CNC. In this lesson I want to go over the toggle function and the multiswitch function. The toggle function allows you to assign a single momentary button that will latch a signal true and false. The multiswitch function allows you to use two buttons to switch between multiple selections within your Linux CNC environment. So to get started with that, I have a new machine simulation that I just started. The only change that I've made to it was I copied and pasted the HAL UI signals with the load USR, HAL input, USB at the top. To get started, I want to do a load RT toggle, and I want to add F toggle.0 to my servo thread. We'll open up Linux CNC. We'll home out, go into our HAL configuration. Under the component section, we can see that we have toggle, and under the pin section, we can see that we have toggle.0, in, out, and time. Time is just the amount of time it takes to process the command. If we go to our watch menu, we can have toggle in, toggle out. To show you real quick, if I go to my main screen, let's say we want to toggle this rabbit button between rabbit and turtle. If we go to the Linux CNC help documentation, we can see that gmokupi offers a pin called gmokupi.jog.turtle-jog. That allows us to assign a keystroke or a button to this icon here and toggle between the fast movement and slow movement. To try that out, I could do a net. We'll call it turtle-rabbit. We'll apply the gmokupi.jog.turtle-jog, and I'll assign that to input.0.btn-a on our PlayStation controller. When I go to my watch list and I go to input 0 button A, and I go to Linux CNC, we can see that when I press button A, the turtle pops up. But now when I take my finger off of button A, it goes back to rabbit. If I want turtle to be the default, I would do basically the same command. So I'll copy that, but I'll do an unlink P, and we'll unlink input.0.button-a, and we will link up button A-not. So we'll add that to the watch list. So now we have our watch list called up with button A and button A.not or -not. When I press button A becomes true, and button A-not becomes false. And let go, and it goes and reverts back to its original state. If I go into Linux CNC, we can already see that the turtle has been assigned. When I press the button, now I get the rabbit. But again, the downside to this is that I have to hold the button in because it's a momentary switch. So to get around that, what I'm going to do in my custom post GUI HAL, down at the bottom, I'm going to say net, and we'll say turtle dash btn for button, and we'll also add net turtle dash select. In this case, we will assign the button of input.0.btn-a to toggle.0.in. So now we're passing the input into the toggle command, and once that input goes into the toggle, it now can send out from the toggle command as the latching button. So in our turtle select, we'll say toggle.0.out, and we'll tie that to the gmokapi.jog.turtle-jog. It doesn't really matter which order you put this stuff in that I've found so far. It's just what's comfortable for you. So I'll reload LinuxCNC. Home it out like we always do. And we'll notice that, okay, the rabbit is active, but now when I press button A, the turtle comes up and it latches, it stays. If I press it again, it goes back to rabbit. Press it again, back to turtle. So now you can see I'm not holding in the button, and I can show you that in the HAL configuration. I'll go to my pins, input, 0, button A, add that to the watch list, button A not, put that on the watch list as well. You'll see that the button is still momentary, but when I go to LinuxCNC, it's toggling on, off, on, off. Or at least it's latching the turtle. So now the default when we first fired up LinuxCNC was the rabbit. And again, all we have to do is change the input status to input button A dash not, save, we'll reload LinuxCNC, home it out, and we can see that we have our turtle. I press button A, and now it latches the rabbit. So the next thing I want to add is the multiswitch command. Now the multiswitch command is something that kind of eluded me for a while. It was something that I didn't find until just recently. I've been using LinuxCNC since April, and since April I've wanted a way of toggling between all of the jog increments that are listed in gmokapi. Continuous, 0.1, 0.05, 0.01, 0.005, so on and so forth. It was only until I found this multi-switch that I was able to do that. Now, if you know your LinuxCNC keystrokes, if you press capital I, it will increment down through the jog increments, and if you use lowercase I, it will increment up through the jog increments. I didn't want to use a keyboard emulator for that functionality. I wanted to do everything strictly in HAL. I asked other people, and I was told that it would be Python scripts, and everybody else just said just use QJoyPad, and that wasn't something that I wanted to embark on. I wanted to keep everything strictly within LinuxCNC. I don't want to use third-party software to do things that I know in my heart of hearts I can do as long as I figure it out. So, to get started with that, the nomenclature is load-RT, multiswitch. CFG is configuration, equals, and then you put in the number of pins that you want to assign to the multi-switch. I'll show you that in the HAL configuration. To do multiple instances of multi-switch, you would use a comma, and you would just put another value for the next series of multi-switch. So 8, 6, 9, and 24. In this case, we're only going to use the one instance, and we're going to assign it to 8 positions. 8 positions because if we look at our help menu, we have HAL increment pins that we can assign. 0 through 6 is 7. And then there's an empty pin that we have to assign at the top in order for it to give us what we need and not alarm out. I'll show you that. So to get started with it, we'll save our we'll load our T multi-switch, then we'll add F multi-switch .0 to our servo thread. We'll save this. We're going to open up LinuxCNC. Take it out of vstop. Home it out. We'll go to our HAL configuration page. Look at our components. And we see multi-switch. We go to our pin section. We have multi-switch pin section, multiswitch.0, bit 0 through bit 7. We have a down and an up. So if we add those to our watch list, we also want to add our input buttons that we want to assign. We're going to assign, I'm not 100% sure, so we'll just add our PlayStation controller buttons to our watch list, and we'll press the buttons that we want to use. In this case, I want to use button Z, and I want to use button TR. We want to assign a down, and we want to assign an up. So I want to assign my up to button Z and my down to button TR, because up is going to go down through the increments, increasing, and down will go through the increments in the reverse direction. So it'll go 7, 6, 5, 4, 3, 2, 1, 0. To test that, we can do a net, and we'll say inc up, and we'll assign that to input.0.button dash, double check it, TR. And we'll assign that to multiswitch.0.up. Go to our watch list, and we'll use the button TR, and we'll see that it now toggles down through those increments. We'll do the same thing for the down. We'll increment, we'll say inc down. Actually, before I do that, I want to copy this to my custom post GUI HAL. Now we can change this to down, so DN. We'll change it to button Z, and multiswitch .0 .down. Copy that, paste, go to our watch list. So we know that the up is working, but now when we press button Z, it's now going back through the increments. At this point, I'll save my post GUI HAL. At this point, we want to assign each of these multi-switch positions to a HAL pin. Those HAL pins are neatly laid out for us in the help menu. gmoccupy.jog.jog-inc-0 through 6. I'll copy the first one, go to my post GUI HAL, and now I'm going to say net inc 0. We'll connect that to gmoccupy.jog.jog-inc-0, and we'll tie that to multiswitch.0 double check bit-00. And we'll just go through and we'll create all of the increments that we're going to need. So really I can copy the entire line and then just change the values. We could also do this in the HAL configuration and just test each one of them if we really wanted to. But because there are so many net assignments in this command, it just makes more sense to do it this way and not have to worry about fighting with the HAL configuration. So we'll save this. I'll close LinuxCNC. We'll open it back up. And we notice that as soon as we open it up, we get these alarms that pop up because it's trying to call up the continuous command before LinuxCNC has been started. So we can just close these out, and I want to show you a little trick to get around that. But right now, if we go to our HAL list, or HAL configuration here, go to our watch list. As a side note, you can save watch lists under File, and you can say Save Watch List, and that will save all of your watch commands, but it's good practice. So we'll go to multiswitch 0, and I'll just re-enable all the multi-switch. We know that the down and the up increments already work. If I go back to my main screen and we look here at the jog increments, we can see that now I'm able to multi-switch through those increments. It actually seems like there's one more. Yeah, there's one more on here than there's assigned in my list. The help menu for gmoccupy says that you're limited to 6. I do believe that you do get 7. I'm going to try that out. I'll save, close, and if it bombs out, then that just goes to show that you can make mistakes and doesn't matter because you can just go back and fix. Alright, so now we toggle down. Yep, so we get that full selection all the way through. So now we get that alarm that comes up when we first fire up LinuxCNC. The way that I found around it is if I go into my post GUI HAL, there is a little bit of kind of dancing that you have to do. What we do is we'll use our increment 0 to just assign a dead, basically an empty bit. And then we will, I'll call this increment dash none or dash nil, something like that. And then I'll copy, paste, and I'll say increment 0 is jog increment 0, 1, 2, 3, 4, 5, 6, 7, and multiswitch. It's going to be bit 1, 2, 3, 4, 5, 6, 7, 8. And now at the very top, I have to make my CFG 9, and that gives me just an empty multiswitch bit that has no assignment. I'll save that. Reload LinuxCNC. You'll see that we don't get the alarm anymore, but there's also, you also have to press the button when you get to the very top. In order to recycle to the bottom, you have to hit the button twice, and in order to get from the bottom back to the top, you have to hit it twice again. So that's the only limitation. So we have down, 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 down to get back to the top, and then up, up to get from top to bottom. Think of it as a failsafe, I guess, because you toggle through and it's like, all right, well, you're already at continuous and that's where you wanted to be, and you hit it one too many times, you actually have an extra time that you can hit it before it goes back and you're only moving at a tenth of a thousandth per click. Alright, so just a quick postscript to this video. As I was going through the editing stage, I started playing around with some HAL logic, and I figured out a way to circumvent the alarms and also get rid of the double hit at the top and bottom of the incremental selections. So if you look, now I can go all the way through. If I close LinuxCNC, open back up, turn the machine on, now I have jog selections without the double hit. To do that, what I did was I tied in, there was a under halui.machine.isOn in my HAL configuration, there was already an assigned pin for halui machine is on. So it was tied to signal machine-is-on. So that's located somewhere in the master HAL file. It wasn't in here. So what I did was I just piggybacked on top of it, and I did a net machine is on, halui.machine.is on, and honestly I didn't even need that line there. I could just take that out because it's already existing. I assigned that to an and 2.0.in 0. If you watch my classic ladder videos, again, you will see a good breakdown of and, or, and XOR for both classic ladder and HAL in that tutorial. So I don't really want to go too far into it, but I assigned machine is on to an and 2.0 in pin. Down here, I created a net inc on off, which could have been any name really. Could have just been inc after power, something like that, or inc PWR dash on. That net command is tying to the second input of the AND statement, which is also linking to the multiswitch.0.bit-00 that was giving me the hard time. After that, I have a net increment 0 tied to gmocopi.jog.jog-inc0 using the AND 2.0 output. That's the important part right there, is that we have to be able to leave the machine in the off state, not have the multi-switch try to assign itself to the gmocopi jog increment, because bit 0 is true on power on, but because we're passing it through the AND gate, we have to wait for the machine to actually be on before the bit for AND 2.0.out goes true to enable the multi-switch bit 00 and assign it to gmocopi increment 0. So there's the fix for that. I'm not recording an entire new section of video. Figured I would just add this to the end of it as a postscript. So again, thank you for watching and hope to see you soon.